anybody else having a hard time seeing the videos on any of the homework?
It's not very easy to find, but I found it.
Okay. So I haven't heard of this. Like, where did you find it?
It was in the helper's office. Yeah, it'll show you.
So which homework was it?
Section
8-2. Do you remember which number?
It was like section 7 through 11 or something like that.
Alright, so let's jump right into it. Okay, yeah. So it has the instruction.
Okay.
Watch a section lecture. Right? Some of the ones that the people who made the course, they pick these ones where you have to watch something and then answer questions about it. I didn't realize it was that difficult to find the videos because the past couple of years no one's asked me about it, but I'm glad you brought it up. But he said in the question help you. Is it under the video?
See, mine doesn't look like that.
Really? It doesn't look like that.
At the top it actually says help me, it doesn't have the video part.
Really? Be like that.
I didn't know if I needed to ask somebody or something.
It's supposed to look the same as this to where the moment in my hand. So is this what you normally see when you've done it? Is this what you normally see? And then you just click on one of the... Okay.
I'll try to go try after this, so they like doing that.
Yeah, just keep me in the loop. Let me know if it's fun. But whenever you click question help, it doesn't say any of these?
It says help me at top, it doesn't say anything else.
Okay. Is this what yours says when you click on it? The video helper?
Yes.
The help me? Okay. Which browser are you using?
Google.
Chrome? Okay. Yeah. Yeah, I'm using Chrome right here. Howden,
Yeah.
Clark, Amina, Cruz, Davis, Echeverria, Foster,
Here.
Cassell, Jackson, where's Jackson? Oh, Color, making sure. Daryl, Gorniak, Larissa, Rolanda Lou, Moment, Miriam, Marshall, Morales, Murphy, here, Hornet, Nelson, Perry, Robertson, Robinson, Skiro, Self, Sir, Snurl, Stephen, Hornet, Wade, Wildy. Okay. Anybody that came in after us started? All right. Okay, so somebody just walked in. Oh, Kevin. All right. What's last name? Wade. Thank you. Questions on anything before we get rolling? All right. Bless you. So 8.7 is next on our list. And it's still probably just some stuff you've seen before that we just need to hash out, roll over everything, make sure there's no cracks in what we're doing. Still building up to solving here. Okay? So the only key terms we've got here are numerical coefficient and combining like terms. What is a coefficient? Okay? Yeah, that is the number portion of any term. So if you've got a term, the coefficient is just going to be the number portion. Them putting the numerical thing in front of it really is just kind of redundant and overkill. You could just say the word coefficient and it means the number in front. Okay, so the practice number 1 here, it says find the numerical coefficient. Right here, that would be -4. So what would it be in letter B there? 15, right? What about in C? 1. 1. -1. -1. -1. 1/4. There's a 1 in front of the Z here, right? And 4 is also part of the number portion of the term. So you would actually list 1/4 as the coefficient there. Okay. Also, don't forget that when you have something like Z over 4, I can rewrite that another way as 1/4 Z. It actually means the same thing. It just depends on which way you'd want to focus on the z. Later on, when we're solving equations and things like that, z over 4 might be useful for solving. But in this section, when we're combining, the 1 over 4z might be more useful because it focuses on the 1/4 rather than the z itself. Okay, so numerical coefficient, just coefficient, and that's just the number portion of the term. Combining like terms, what does that mean?
To combine the things that are like.
And what categorizes things as like terms?
If it has like same variables.
One extra little tidbit there. You're absolutely right. Morning, Clarissa. Like terms. This means that they not only have the same variable, okay, but don't forget you can actually have some exponents mixed in there. So what you really need to look at it as the same variable combination. So if I have 1x and 2y's and 3z's, something is like terms if it has that exact same combination, not 3x's, 2y's, and 1z. Okay? And then the actual order that they appear does not matter. So for example, two things that are like terms would be 3x squared y and let's say 17yx squared. These would be like terms. Because it doesn't matter which way I write the x's and the y's as long as it's the same amount. Because if it's the same amount, then they are the actual same object, and all I'd really be doing is counting. When we're talking about like terms, it's really just a method of counting objects. Okay? So I have 3 of what object? The object called x squared y. Right? This is technically the same object because multiplication I can do either way, right? X squared, y. So I have 17 of this object, yx squared. And then those are like terms because it's the same object. Whereas if I had something like x z to the third, okay, is not like with 11 x to the third. Okay, those are not the same. Even though they both have x and z, one of them has 3 x's, the other has 1 x. One of them has 3 z's, the other has 1 z. Okay? So they need to not just be the same letters, you need to pay attention to how many of each object they've got. And then you can say whether they're like terms or not.
What's the same variable?
That's what this is showing, right? The same variable is x and z, right? But z has the cube, whereas here x has the cube. So that's technically different exponents. Because here x is to the 1. Here x is to the 3. Yeah? What's that? Oh, same variable combination. Did I misspell it?
Oh, yeah.
I very well may have. Because I'm horrible at that. Is it an I right here, maybe? That's probably right, yeah? That might be better.
Combination.
Apologies. Okay. So now we're just going to go through this list here and talk about if they're like terms or not. 7x squared, negative 6x cubed. No. Why not?
Two.
Different exponents, right? So this is a big fat no. Okay? 3x 3x squared y squared, negative x squared y squared, and 4x squared y squared?
Yes.
Yeah. Does it always have to be talking about two things? Right? Like right here I gave examples with two objects. But it can be more than two. Yeah, these are like terms. Negative 5ab, 3ba.
No.
Because remember, it's not about the order, it's about how many of each. He has 1a, he has 1a. He has 1b, he also has 1b. So they're identical, they're like terms. Okay? 2x cubed, 4y cubed.
No.
The exponents are the same.
No.
But that one not the
Different
same.
letters, right? Yeah. I thought they could get you on that. Negative 7m4 and 7m to the 4th.
Yes.
Yeah. Those are the same. Okay. So why would it be important to know when things are what we call like terms? Right. And that's what this is built into, right? We defined like terms, and now what we actually want to talk about is combining like terms. When you have two things that are like terms, like 5x plus 7x, right? What's the answer if I combine 12x? There are two different answers there. Is it 12x or 12x squared? 12x. Okay? When you're multiplying is when you get to x squared. But look, here's the actual steps. Since these are the same, could they have been distributed? Remember the distributive property we talked about last time? And we went in reverse? Is it possible that this could have been a distributive property, like this? Yeah. Where I've multiplied x into both? So this and this are actually the same thing, I've just not distributed it. But then can I do 5 plus 7? Those are just numbers now. Right? Yeah. So 5 plus 7 is 12x. Now normally, and probably in just about every other math class you've done, they've never shown you this. This actually becomes important later on when you want to start doing more complicated equations. Not in this course, but the reason that this works, because they're like terms, that's what allows me to undistribute it. If they were different, it wouldn't be like a distributive property. And then they wouldn't be able to be combined. Right? So we say like terms, they're going to be the same combination, because what I'm actually doing is ignoring the x. Oh, they're the same. I can just kind of forget about that x for a minute. And then focus on the coefficients, 5 and 7. And then I'm just doing the action that's in between there. Okay. So 9y minus 4y. You don't need to do all the steps like I did there. I was just kind of throwing some stuff out there in case it sparked an interest. I know, how crazy am I? We're not interested. Right? It's too early in the morning. Okay, so 9y minus 4y. What do you think? They're like terms. 5y, right? Yes. 5y. Okay. 11x squared plus x squared. It's 12x squared, right? Because it's just 11 plus 1. Because they're like terms, right? That's what we're looking for. Are they like terms, yes or no? And if yes, combine. Okay? 5y minus 3x plus 4x. What about the 5y and the 3x? No, they're not like terms, right? Almost. You have the right idea though, right? These are the ones I'm combining, and I need to do 4 plus negative 3, which is what? 5y plus x. Yeah, right? Because if I put $4 in my bank account and take 3 away, right, I write a $3 check, I've got $1 left in the bank. Or let's talk in millions if we're doing bank accounts, right? If I have 4 million, I take away 3 million, right? That's much more fun to talk about bank accounts. Because I know it'll never happen. Well, you gotta play the lottery to win it, right? I gave up on that one. All right, 14m squared minus m squared plus 3m squared. Any like terms happen to be floating around in it? All of them, right? They're all m squared. Yeah. Does it matter what order I add them in? No, right? As long as you make sure that that negative stays with the 1 on this one, right? But let's just go left to right because that's order of operations, yeah? 14 minus 1 plus 3 more is 16 squared. Okay? What if you came across something like 3z plus 4 cubed? Strange letters, but that's not important, right? I can't combine them, right? So what do you say? Yeah, you leave it like this, right? Or you could also put already simplified. That's perfectly legal as well. Kind of like shaking your finger at it. It's already simplified. Here's another question for you. Why do firemen wear red, white, blue suspenders? Keep your pants up. Red, white, blue. Very good. Okay. So right here, next. Simplify each expression by combining like terms. Same idea, right? But now they've got a couple of things going on. 7y plus 2y plus 6 plus 10. Kevin's got this. Boom. 9y plus 16, right? Because these two are like terms right here. And I can do just those two, since those are the like terms, and 7 plus 2 is 9. And 6 and 10 are also a separate pair of like terms. Yeah. So I've got 9y plus 16. Okay? Negative 2x plus 4 plus x minus 11. Yeah. You're seeing the things that are alike, right? You see the x here, and I see the x here. Now, if you were to go through step by step, like we were doing the properties last time, I'd have to actually reverse the order on some of these and then combine things by getting things grouped together. We don't need to go through all of that. Just look for what are like terms. I can see the x here and I can see the x here. So I'm literally going to do negative 2 plus 1. Right? Negative 2 plus 1, which is negative 1. Or just negative x. And then 4 and 11. Those are also like terms because they don't have any variables. And 4 minus 11. Anything I'm going too fast with this? Questions only. Yeah, go ahead.
So you had to
multiply when we add and subtract, right?
Okay, so we're not multiplying right now, right? It's all addition and subtraction, right? That's why we're not getting anything with higher exponents or anything like that. But the second thing you said, yes, we're adding and subtracting whenever they're the same variable stuff. Yeah? Okay, so we're looking for that pattern. Does that help? Y'all good? All right. 3z minus 3z squared. Yes, that one is already simplified. 3z minus 3z squared. Okay. 8.9y plus 4.2y minus 3. 13.1y minus 3. Is the 3 like terms with anything? No. Why? Because they know that's the same. No, I'm saying, look, why? Gotcha. Okay. So as he's saying right here, these front two are the like terms. Have a y. So I'm literally performing 8.9 plus 4.2. And it's okay if you have to do that on the side. There's nothing wrong with that. So I get 11, I carry the 1. 8 4 is 12, so that's 13. Okay? So then together, that's 13.1y. And then I've still got the minus 3. Nothing has changed on that term. You didn't have anybody to pair with. Did y'all hear that crocodile can grow up to 15 feet? They usually only grow 4, though. Okay, so find each product using the distributive property. So now we're multiplying, right? First of all, check inside of your parentheses whether or not there are any like terms. That will make your life a little bit easier for afterwards as well. Okay, so right here, I'm noticing 11y and 6 no variable. So there's no like terms in there. After doing a distributive property, that should not change. Okay, because everybody's getting the same multiplication. So right here, I'm going to multiply 3 times 11y, right? And 3 times 6, plus 18. Yep. Still no like terms, right? If there aren't any before, there shouldn't be after. Here I'm distributing not just a 4, but a negative 4. So I'm going to be multiplying negative 4 times x, negative 4 times 0.2y, and negative 4 times negative 3. That should give me negative 4x, right? 4 times 1. And then 4 times 0.2, 0.8. In this case, negative 0.8 with a y. And then negative 4 times negative 3. Don't forget double negative, right? All right. Plus. Right. Okay. And then I've got 3x, 2y, z, and 1. Still no like terms here, right? What am I distributing? Negative and a 1, right? So I'm technically doing negative 1 times 3x times 2y times z times negative 1. Result? Maybe. Very good. We talked about distributive property a little bit last time too. Yeah. Remember, the big reason that we use distributive property is usually there's some sort of grouping there, right? The parentheses, and we don't want that grouping. We'd rather have it not grouped. Questions on anything yet? Okay, so now mixing distributive property in there with like term combining. So there'll be a couple of stages to each of these problems. We'll distribute first because we don't want the parentheses. And then afterwards, we'll check for combining like terms. So 4 times 4x minus 6, and then plus 20. I'll start by distributing the 4. Yeah, those are like terms, aren't they? Negative 24 and positive 20. Yeah. With me on that one. Yeah, go ahead. Right, so you're talking about the minus? Yeah, very often the minus sign in algebra just gets rammed with whatever's to the right of it and just becomes a negative. So if it helps, you could actually rewrite this as 16x plus negative 24 plus 20. Just always write addition, and if it happens to be a subtraction, just couple it as a negative. That's completely legal too. Okay? All right, next. 5 minus 3x plus 9 plus 6x. Okay, so what am I distributing this time? Negative and a 1, right? If you're saying distributing just a negative, that's fine too. I'm just bringing this out to help in case some people need that extra number. Okay, so I'm distributing negative 1 times 3x and negative 1 times 9. Yeah. Now real quick on the side, sometimes when people come up against one of these types of problems, like for example letter B here, some people are tempted to add that 8 plus 11 first. Why wouldn't you do that? Order of operations, right? Because what operation is this? Multiplication. So even if you had done the parentheses first, if you could, you still wouldn't add 8 plus 11 because multiplication has to happen before addition, right? So make sure when you're looking at this, you're seeing the order of operations, not just left to right. Oh, get it done quick, right? Watch your steps on those. Okay, so is 5 like termed with anything here? With the 9. 5 minus 9. Negative 4. Yep, that one's 5 minus 9 is still negative 4. I went to the meeting last night. They didn't change that one. Yeah. Negative 3x plus 6x. Those are both x-like terms. 6 minus 3 is 3. Therefore, plus 3x. Questions on that? Okay, -3 times 7x plus 1 minus 4x minus 2. There are two distributive properties this time. I'm going to distribute the -3 to the 7x and the 1. And then I'm also going to distribute the -1 here to the 4x and the -2. Okay, so what do we get? -21x minus 3 plus 2. Do we have any like that? Are you sure? That's right. Those are both. -21x minus 4x. They're both negative, so I add the numbers, -25, and I still have x. So -3 plus 2, those are both like terms. And that gives me minus. Yeah? Okay. Give it a shot. Okay. Okay. 22y minus 9. Questions yet? I have one. What do you get when you cross a snowman and a vampire? Frostbite. Okay. So that one there at the top says subtract 9x minus 10 from 4x minus 3. Now remember, be careful with the wording in these. Right. From is the preposition, meaning the 4x minus 3 is my total, and I'm taking the other thing away from it. So I'll start with 4x minus 3, and I am taking away 9x minus 10. Now, I put those first parentheses on there for aesthetics, which means just to help the way it looks. Right? I know math's pretty ugly. I'm trying to help it out as best I can. But I don't actually need these here because there's only a 1 in front of it. Distributing a 1 doesn't do anything. Anything times 1 in itself. So technically I don't need those. I could have just written this, but I was trying to make a point. However, on the next one, it's subtraction. So I do have to distribute a -1. What's that going to give me here? And then combining like that. Plus 7. Yeah. So now we're just translating. 3 times a number subtracted from 10. Yeah. The from, right? From means the 10 goes first. 10 and then subtracting 3 times the number 3x. Does it have to be 3x? Could it be 3n? Right. In the direction here, right? Let x be the unknown number. If it hadn't said that, though, you really could use any symbol you want. I've even used stickman before. That works too. Okay. The sum of a number and 2 divided by 5. What's sum? Yeah, that's plus. Okay. So number and 2 is x plus 2. And then you see where the comma is here? There's a separation, right? So what is actually being divided by 5? The whole thing, yeah. Whereas if the comma wasn't there, the sum of a number and 2 divided by 5, right? Division usually comes first. So you would do 2 over 5 and then x plus 5. But in this case, with the comma, it's grouping, right? So x plus 2 is grouping. 3 times the sum of a number and 6. Now, right here, the times is focused on the sum. Not 3 times a number and not 3 times 6 specifically. 3 is times the whole sum. So when you see something like that, don't forget, that's a grouping. 3 is times the group of objects that are summed, and they happen to be a number and 6. Yeah. That's it. And then simplifying, if possible, they would probably want you to distribute that. 3x plus, okay, I think you said 60. All right, 7 times the difference of a number and 4. 7. There's definitely a 7 in there. Yeah, parentheses, good. Right. Difference of a number and 4, x minus 4. Difference is subtraction. You keep the order that they listed in. Simplify.
7x.
20. Yeah. Then change that. Questions on anything in this section? Why did the coffee file a police report? It was mud. I will see you guys Wednesday with more corny jokes. Thank you for playing.